This project is about the analysis and design of a portal frame structure using Revit, SpaceGas, and Navisworks CAD software. The design parameters of the portal frame structure for our group were a raft load of 14 kilonewtons per meter, a building length of 56 meters, a frame span of 20 meters, an eaves height of 9 meters, a roof pitch of 6 degrees, and a spacing of 8 meters between the frames. The spacings of the frames is an integral part of the structure's construction. If the spacing is too far apart, the purlins, girts and bracings may reach over the design lengths, which could cause structural instabilities. Likewise, if the spacing is too small, the amount of materials used may exceed the desired budget. For the rafters, we used 406 by 140 by 46 universal beams, and for the restrained columns, we used 457 by 191 by 74 universal beams. The spacing measurements for the purlins, girts were taken from the Lagerslat Spandeck Design and Installation Guide. For the purlins and girts, we used single span 15,012 Z sections. The Australian standards AS 4100, AS 3600 and AS 1170 were used to assess the structural members of the portal frame. We then created a visual timeline of the construction of the portal frame using Navisworks. 4 load combinations act on the portal frame, consisting of dead loads, live loads, internal and external crosswind pressure, and internal longitudinal wind pressure. For load combination 1, distributed forces act downwards. For load combination 2, the rafters have distributed forces acting on them. Downward forces act vertically while the upward forces act perpendicular to the rafters. The columns have distributed forces acting on them both, except to the left of the right column. For load combination 3, the distributed forces are symmetrical and act both downwards vertically and upwards perpendicular to the rafters and outwards on the columns. For load combination 4, the rafters have distributed forces acting both inwards and outwards perpendicular to the rafters and a distributed force acting downwards. For the columns, distributed forces act inwards and outwards, except to the left of the left column.